Hello, welcome. In this lesson, I'll show you how to do analysis of variance using Excel. I have my information which contains the fertilizer types of fertilizers and their effect on the yield of maize. So we have three types of fertilizers and the fertilizers we applied on different on 10 maize uh, in each plot, and the yield of each of the maize were measured according to the fertilizer applied. So we are going to be using analysis of variance to compare um, if there's a significant difference in the yield of maize uh, according to these three fertilizer. So before that, let me quickly show you a few things you need to know about um, ANOVA. So ANOVA, okay, analysis of variance is a statistical formula or technique that is used to compare variances across the mean of different groups. So a range of scenarios is used to determine if there is any difference between the mean of different groups. So in this case, ANOVA compare the variances across the mean of different groups. That is, when the groups are more than two. When we are having just two groups, it's always preferable to use the t-test. But when the groups rather are more than two, since we have three, four, and the likes, then analysis of variance is appropriate. And there are types of ANOVA that we have. We have the one-way ANOVA, or the single factor analysis of variance. Then we have the two-way ANOVA, which is two factors, and then we have the two-way ANOVA with replication. That's two factors with replication. In this lesson, I'll show you how you can analyze the three types of ANOVA using Excel. So when we talk about one-way ANOVA or single factor ANOVA, we are comparing the variances of different group across a single factor. Across a single factor. Like the case of fertilizer I showed you, you would notice that what we are comparing here is just the effect of fertilizer. So the factor here is the fertilizer effect. Then in two-way ANOVA, we compare two factors. That is, we compare the variances across different groups of two factors. So can be another factor can be added or examined to explain the effect on the dependent factor. Now, and then we have another with replication. That is two factor when you are repeating it, where when you repeat the experiment or replicate it. Now, the hypothesis statement is there's no significant difference in the means of the group. That is the non-hypothesis. And then the alternative hypothesis is there's significant difference in the means of the group, just like the way we have it when we looked at t-test. If you have not watched my video on t-test, please go back and watch it. Now, here we have decision rule, and the decision rule says reject H naught if F is greater than F critical. We're still going to come back to this, and then this the alternative decision rule. But before we discuss this, let's just run analysis of variance in Excel and examine the results. So to do that, click on data analysis. Now the first thing you will see is ANOVA single factor. So this is one-way ANOVA. So click on ANOVA single factor and click OK. So once you have clicked OK, then it says the input range, that is the range of cells that you have. So the input range, I would input everything I have in my data set. So check this box and highlight everything. I'll be from A1 to C11. So now group by columns and then labels in first row. Yes, there's a label in first row. So you check it. Then the alpha, which is the level of significance, by default is 0.05. You can increase it or decrease it as you wish. Output options, where you want the result to be displayed. So I prefer to have it in this current worksheet. So I'll just select this cell and then everything is set now. I click OK. So now, so what do I have? I have this as my result. We have the summary, and which gives us the count, that is the sample number that we have, which is 10. And then the sum for each fertilizer, for each group, we have the sum for fertilizer 1, we have 323, then 302 for fertilizer 2, and then 276 for fertilizer 3. Then this is the average of each group, and this is the variance. So ANOVA, this is the ANOVA table, and basically what we need is the F statistics and then the F statistics, the p-value, and the F critical. Like I told you, the F critical is the table value gotten from the table, from the statistical table. So there are two ways to make a decision to determine if there's significant difference in the mean of these three fertilizer or not. So how do we determine that? Let's go back to our decision rule. Our decision rule says reject H naught if F is greater than F critical. Okay, now this is the value for our F and this is the value for F critical. Now, is this value greater than F critical? No, this value is not greater than F critical. This value is less to F critical. So that implies that we would not reject H naught. Now, so if we did not reject H naught, that means our non-hypothesis is the correct. We are adopting the non-hypothesis. That means there is no significant difference in the mean of the group. That means what we are saying is that fertilizer 1, fertilizer 2, and fertilizer 3 are the same. There's no significant difference in their means. Alternatively, we can also use our p-value to make decision. The decision rule is reject H naught if p-value is less than level of significance, which is 0.05 that we have specified the other time. So let's check. Now this is our p-value 0.257957. Is this value lesser than 0.05 or greater than 0.05? So we find out that this value is greater than 0.05. So that implies that we are not going to reject H naught because the rule says we get H naught if p-value is less than 0.05. But in this case, this value is greater than 0.05. So we do not reject H naught. So that implies that fertilizer 1, fertilizer 2, and fertilizer 3 are the same. They have the same effect on the yield of maize. So advising a farmer, you would tell that farmer that any of the fertilizer is appropriate to use. So basically that is what we do in one-way analysis of variance. Also, we can also look at two-way analysis of variance. Now, in two-way analysis of variance, we will notice that we are dealing with two factors, and the factors are fertilizer 1, fertilizer 2, and fertilizer 3. Then the soil type, soil 1, soil 2, soil 3, soil. So these are the factors that can actually affect the yield of maize. So this is an example of two-way analysis of variance without replication. So because we are dealing with two factors, which is the soil type and also fertilizer, types of fertilizer. So let's run through ANOVA and see how our result will be. So come to data, Click on data analysis. Now this time around we click on two-way ANOVA without replication. ANOVA two-factor without replication. So we click on it and then click OK. Now it asks for the input range, so we select everything together, everything. Now once that is done, we select label to show that the first row and the first column are labels. Then our alpha is 0.05 and our output range, we will select a particular cell where our result will be displayed. So everything is set now. We click OK. So this is the result of our two-way ANOVA without replication. So see the summary table for soil type and for fertilizer. You will see that count soil type is 3. Yes, the soil type is 4, but we have 3 observation underneath our soil types is 1, 2, 3. Yeah. While fertilizer we have 4 observations 1, 2, 3, 4. So then this is the sum of our soil type. This is the sum of soil 1, soil 2, and up to soil 4. While this is for fertilizer 1 to 3, and these are the average and variance. Now, so let's go back to the ANOVA table. So in the ANOVA table here, we have the source of variation, we have the rows. The row here is talking about what we have at the row in our data set, which is the soil type. So I can change this to soil type. While we have the column is what we have here, which is fertilizer type. So that is that. Then we have the sum of square, the degree of freedom, and then basically what we need is the F statistics value, the P value, and the F critical. So we compare each of these value. So now F value, don't forget our rule says that to reject H naught if F is greater than F critical. So we are still working with that rule. So if you look at it, you find out that this is the value of our F 0.02. Now is lesser than the F critical, which is 4.75. So this implies that we are not going to reject H naught. So that means the soil type is not significantly different because our H naught says there's no significant difference in the means of the group. So that means soil type is not significantly different. So then the same thing, we also use p-value. We can also use p-value here. We compare p-value with 0.05, just like we have it here. We get H naught if p-value is less than 0.05. So if you compare p-value with 0.05, then you will notice that this p-value is greater than 0.05. So that means we will not reject H naught. Now also for fertilizer, let's compare this our F value 0.69071 with F critical 5.143253. You will notice that this value is lesser than this value. So we will not reject H naught. Also p-value, notice that this p-value is greater than 0.05 and is supposed to be less because the rule says you get H naught if p-value is less than 0.05. But in this case, our p-value is greater than 0.05. So we are not going to reject the null hypothesis. So basically, that is t-test two-factor without replication. Now let's go to ANOVA, rather ANOVA two-factor with replication. Let's go to ANOVA two-factor with replication. So in this case now, this our data has replication. We are still working with the two factors, soil type and fertilizer type now. But you notice that under soil type, there are 3 replicates of soil type 1. Then soil 2, you have another 3 replicates. Then soil 3, we have another 3 replicates. So what we're using here is ANOVA two-factor with replication. So to do that, let's go to data analysis, and this time pick ANOVA two-factor with replication. Click OK. Now it says input range. We select all the range of data that we have and then select this box. Now it says row per sample. Row per sample is the number of replication that you have, and in this case we have 1, 2, 3. So the row per sample is 3. That is, the number of replicates is 3 or at 3. Now we have the alpha, which is 0.05 by default, so we'll just leave it at that. Then the output options, so we check this box and then we select the cell where we want the result to be. And once that is done, we click on that box and everything is set here. Now we click OK. Then we have our result here, quite large. So now this is the summary result, and this is for soil 1, and for soil 1, fertilizer 1, 2, and 3 in soil 1. What do we have? You have the count, the sum, the average, and the variance for each fertilizer in soil 1. Also the same thing for each fertilizer in soil 2 and that of soil 3. And then we have the total. We have the total. Then this is the ANOVA table for each variable. Now for sample, this is for fertilizer, and it is for soil type rather, and the column is for fertilizer, so you can just change it. And then this is the interaction effect between fertilizer and soil type. So we can compare this value with this value. Now this value 0.90 is less than F critical, and don't forget our decision rule. It says reject H naught if F is greater than F critical, but in this case it's less, so that means we are not rejecting H naught for soil type. And also the same thing for, if you also use the p-value, this p-value is greater than 0.05, so that means you are not rejecting H naught. The same thing applies to fertilizer, and the same thing applies to the interaction effect. So that implies that there is no significant difference in the mean of the two groups when we use ANOVA two-factor with replication. So basically, this is all you need to know about ANOVA in Excel. Thank you very much.